Whilst I was at a trade show making videos about memory on GigaDevice booth, one demo really caught my eye. It was a GD32 microcontroller controlling a brushless DC motor. A single MCU operating a screen, buttons, taking current measurements through multiple ADCs, but most importantly for the motor, generating a three-phase sinusoidal PWM signal. There's a lot of 32-bit MCUs on the market at the moment, so why would anyone want to care about this one? The short answer is manufacturability, and we're going to be talking more about that later. Joining me today in the studio is FAE of GigaDevice, Tian Peng. Let's go find out some more. Tian Peng, thank you very much for joining me in the studio today.
Yeah, thank you for inviting me to Elias.
Of course. Now, I met you in India at Electronica India, and we filmed some stuff on the GigaDevice booth. I want to know a little bit more about the demo that you were showing. What was the demo doing?
Okay, so the demo that we show during the exhibition is actually a motor control demo. It was using a BLDC demo. So this is the main board that is controlling the motors.
Cool.
So this one is using a three-phase algorithms, and also it could be used as a sensor or sensorless algorithm to detect the rotor positions, and also it comes with a rich features of human machine interfaces, like for example the display and also the knobs to control the different modes and also different speed of the motors. So this will be targeting for the industrial motors and also the home appliances consumers applications which require a motors.
Nice. By the way, that is a really good-looking PCB. What BLDC motors, right? They're sort of all the rave at the moment. Brushless DC, and I'm seeing them in e-scooters. I'm seeing them in e-bikes and more applications. What is required to run a BLDC motor?
Okay, so to run a BLDC motor, fundamentally we require at least three channels of timers, so that will to drive the three-phase motor, and also you will require maybe some sensors to do the rotor positionings, and also on the MCU you will maybe require some ADC channels, at least one or up to three, to do the current sensing as a sensorless method to detect the rotor positions. And also you will require some software algorithms such as 6-step commutations, right, to really configure your timers in such a way that it could drive the three-phase motor efficiently. So I think basically timers, ADC, sensorless, these are the major components or requirements that we'll need in the motor control.
Great. Because at the BLDC motor, essentially you need three phases of full sinusoidal voltage, right? And to do this on your board, you've got 6 FETs there that are modulating a PWM signal that is coming from your microcontroller, which is generating 3 sine waves, 60 degrees out of phase each.
Yes.
Oh, sorry, 60?
Yes.
120.
Yes. It really depends. I mean, if you're using a 6-step commutations, then that will be a 60 degree for each phase.
So it's quite an involved demo, because in addition to the sensors that you're running and the ADCs that you're reading in, and your complex digital outputs that are able to control these 3-phase H bridges. In addition to that, you're also running a screen, right? So it's a pretty involved demo. Why was this demo the best demo to show off what the GD32 is capable of?
So these demos, right, usually come with rich features of human-machine interface. So for example, the display and knobs that I mentioned just now, and it's also could be it could be integrated with different MCU. For example, in GD32, there are F3, F4 series. They're using M4 ARM Cortex-M4 core. This is for the more consumer applications, but also you can extend it to higher end applications. For example, the industrial automations, which having higher accuracies and also higher precisions timers.
I've got one question that I think will maybe put it in the engineers' minds why they might want to choose a GD32 next time over any other 32-bit micro on the market. So if you had to pick, what is the single advantage of using a GD32?
Okay, so GD32 is actually a general purpose MCU. So I mean there are a lot of players in the market. Yeah, but generally I think our advantage is that we have a very competitive price, and also our lead time is also very competitive, and also we are a fabless company. So that means we are working together with a lot of different foundries in all around the world, and also the OSAT, the testing partners in all around the world, so that we can surely commit to our customers in delivering our products. Yeah.
So essentially, anybody who's looking to do something really high volume, right? This is where the
Yeah.
GD32 shines. Low cost, lots of stock, low lead
Yeah.
times. Brilliant. IPXs, if you want to know more about the GD32 MCU, we're going to have a write-up over on ipexchange.tech where you can get a data sheet and see if this might be the right MCU for your next project. Tianpeng, thank you very much for joining me today.
Thank you, Xiu.